Hello everyone, my name is Nadia Zahrina and I'm currently majoring in Management 2023. And today I want to explain about indices or powers. Okay, so if you're curious about indices or powers, then let's keep watching. Okay, so we start from the definition. Definition of indices. Acknowledge of powers or indices as they are often called is essential for an understanding of most algebraic process. So, not that powers and indices are the same. And the introduction. In this section, we will be looking at indices or powers. Basically, they are a shorthand way of writing multiplications of the same number. So, suppose we have 2 times 2 times 2. We'll write this as 2 to the power or index 3. So 2 times 2 times 2 equals to 2 to the index 3. The k-point and index or power is used to show that a quantity is repeatedly multiplied by itself. And this can be done with letters as well as numbers. So we might have a times a times a times a. Since there are 4 a's multiplied together, we write this as a to the index 4. It's gonna be like this. Okay, so a times a times a times a equals to a to the index 4. Okay, so for the first row, suppose we have a to the index 2 and we want to multiply it by a to the index 3. So it's gonna be like this. Altogether, there are 5 a's multiplied together. Clearly, this is the same as a to the index 5. This suggests our first rule. So if we have a to the index m times a to the index n, we add the indices to get a to the index m times a to the index n equals to a to the index m plus n. Okay, so for the second rule, suppose we had a to the index 5 and we want to raise it out to the index 2. So it's going to be like this. This means a to the index 5 times a to the index 5. Now, our first rule tells us that we should add the indices together. So, the result is like this. But not also that 10 is the result from 5 times 2. This suggests that if we have a to the index n or raise it to the index n, the result is obtained by multiplying the two index to get a to the index m times n, or simply a to the index m n. And there is the k-point. And for the third rule, consider dividing a to the index 5 by a to the index 3, so it's gonna be like this. And we can now begin dividing out the common factors of a. 3 of the a's at the top and the 3 a's at the bottom can be divided out, so we are now left with a to the index 2 divided by 1, that is a to the index 2. The same answer is obtained by subtracting the indices that 5 minus 3 equals to 2. This suggests our third rule that a to the index m divided by a to the index n equals to a to the index m minus n. For the fourth rule, let's have a look at a to the index 4 divided by a to the index 4. We are dividing a quantity by itself, so the answer has got to be 1. So it's gonna be like this. And rule 3 tells us that to divide the two quantities, that we subtract the indices, like this. So what we have is a to the index 0 equals to 1. This means that any number raised to the index 0 is 1. So, for the example, like this. And 0 to the index 0 cannot be evaluated. Any number apart from 0 when raised to the index 0 is equal to 1. The fourth rule. Let's have a look now at doing a division again. Consider a to the index 3 divided by a to the index I. Be like this. The 3 a's at the top and 3 of the a's at the bottom can be divided out, so we are now left with this. And now let's use our third rule and do the same calculation by subtracting the indices, like this. So 1 divided by a to the index 5 equals to a to the index minus 5. So negative sign in the index can be thought of as meaning 1 over. And there is the key point. For the sixth rule. So far we have dealt with integer index both positive and negative. And what would we do if we had a fraction for an index, like a to the index 1 divided by 2? To see how to deal with the fractional index, consider the following. Suppose we have two identical numbers multiplying together to give another number, as in, for example, 8 times 8 equals to 64. Then we know that 8 is the square root of 64. That is, if gonna be like this, you can see at the top of me. And now, suppose we found that a to the index p times a to the index p equals to a. That is, when we multiply a to the index p by itself, we got the result a. This means that a to the index p must be a square root of a. However, look at this another way. Noting that a equals to a to the index 1, and also that from the first rule, we see that a to the index p times a to the index p equals to a then, from which 2p equals to 1, and so p equals to 1 divided by 2. And this shows that a to the index 1 divided by 2 is the square root of a. That is, okay, so here's the key point. Okay, so before the closing, I have some examples for this material. For the first one is 5 to the index 3. It's gonna be like 5 times 5 times 5 equals to 125, like this. For the second is 2 to the index minus 2, and it's gonna be like 1 divided by 2 to the index 2 equals to 1 divided by 4. And for the last is 125 to the index 1 divided by 3. It's gonna be like, open bracket, 5 times 5 times 5 close bracket to the index 1 divided by 3. Hence 125 to the index 1 divided by 3 equals to 5. Okay, so those are the examples for these materials.